What's up, folks? It is Thursday night for me, but for you, it is Friday day or Friday morning day. And I'm not with you because I'm driving to Nebraska. You're hanging out with the lovely Miss Schoenweiss, getting some knowledge dropped upon you, and perhaps dropping knowledge on other people. Who knows? Let's find out. We're going to talk about hyperbolas today. Your homework is complete learning guide problems 13 and 14, except for the parametric part of them, because again, we still have not spoken of parametric equations. We will start that on block day next week. But for now, we're going to talk about parabolas. So our objectives are to understand what a hyperbola is. I'm pretty sure I just said parabolas on the last page. I meant to say hyperbolas. We want to understand what a hyperbola is. We want to be able to use the equation and come up with the equation given pieces of information. We want to be able to accurately graph them, identify the foci, or a foci if you're one of those, and identify the coordinates of the vertices. And hyperbolas actually have asymptotes as well, and we want to be able to identify those asymptotes and draw them in as well. So basically everything that we did with ellipses we want to do with hyperbolas, except we also want to understand the asymptotes. So let's get started. I'll keep this as brief as I can. The way you should use this is I'll do an example for you first, and then I'll show you another problem, and you should pause it and do that problem, and then after you're done, I will work out a solution for you, and you can check yourself. And you should please talk to each other and try to make sense of the things that I say in the video in case I'm not making sense because it's late and I'm tired. So let's get started. We want to understand what a hyperbola actually is. And the technical definition of a hyperbola is very similar to that of an ellipse, but it's slightly different. Can you guess what that difference is? And that is a dorky little clue right there. The difference is that we need to be thinking of a difference instead of a sum. If you remember the definition of the ellipse, it was that every point on the ellipse, the sum of the distances to the two foci was a constant value. Well, for a hyperbola, the difference is a constant value. So here's a hyperbola like that. Focus right there. And here we're saying the difference of those two lengths is a constant value. And that is the difference between the definition of an ellipse and the definition of a hyperbola. So that d1, d2 difference is always a constant term. And that should always be thought of as a positive number as well. So the larger number subtracting the smaller number from the larger number. Or just think of it as the absolute value of d2 minus d1, and that is fine as well. So, just like an ellipse, we have some special pieces. We have the center, which we know is going to be at h, comma, k. We have the vertex, which we know will be at h plus a, comma, k. And h minus a, comma, k. Again, just like an ellipse. But notice the difference is the foci here are on the outside of the vertices, unlike an ellipse. In an ellipse, the foci are inside. Here, the foci are farther out than the vertices are. Notice we see an A, we see a C. We don't necessarily see a B at this point. We will understand how that works a little bit later. Notice the line running between the two vertices is called the transverse axis of the hyperbola. If it were an ellipse, remember that would be called the major axis, but this is called the transverse axis of the hyperbola. So I want to show you real quick how connected these two shapes are, the ellipse and the hyperbola. So I've given you the equation here of an ellipse. Let's go ahead and think about what this is going to look like. First off, I know the center is going to be at the x value of 1, 2, 3, and the y value of 1, positive 2 right there. I can tell that this ellipse is going to be a horizontal ellipse because the larger denominator is with the x set of things. So the 9 is underneath the x. 9 is bigger than 4. So that tells me my a value here is 3. My b value here is 2. So a in the x direction, I'm going to go 1, 2, 3, plot my point, and 1, 2, 3 in the other direction, plot my other vertex, and then I can go down 2 from the center and up 2 from the center right there. And I have my ellipse. So that should be review. I don't like how that looks. Now I want to show you how we can change this equation ever so slightly and actually turn this into the equation of a hyperbola. So imagine instead of adding these two terms together, I were to say subtract my y stuff right there. So I'm turning that addition sign into a big minus sign. How would that affect what this looks like? Well, instead of looking like a ellipse like that, it's going to turn into a hyperbola. And it's going to be a horizontally oriented or horizontally opening hyperbola. And it's going to look exactly like this. Boom. Those branches are going to come out there. Those branches are going to come out right there, just like that. Kind of looks like two sideways parabolas almost, except the relationship is different there. But notice it shares its vertices with that ellipse. That's kind of cool. That's kind of special. You can know that it's opening horizontally because your x stuff is positive and the y is negative. Okay, well, what if we wanted this to become the equation of a vertically opening hyperbola? Well, then keep the y positive and make your x stuff negative. Typically, you'd see that written as y minus 2 squared over 4 minus x minus 3 squared over 9 equals 1, but it means the same thing here. I could rearrange this if I wanted to, but that's going to give me a parabola, or I'm sorry, a hyperbola that looks like that. Interesting, interesting, interesting. So on my ellipse, my two foci would be somewhere in there, aligned with the major axis. On the hyperbola, the foci are again, just like the parabola, just like the ellipse, just like everything else, the foci are going to be inside that curve. But you can see that this distance of C now is going to be bigger than the distance of C is in the ellipse, which is a little different. And then if it's vertical, your two foci are going to be there. Again, because they're always in line with the vertices of your graph. So a couple different options there of what this is going to look like. Now we want to be able to make our curves as accurate as possible, and in doing so, we need to be able to sketch the asymptotes of the hyperbola. Yes, those branches, the two pieces, the legs going out, extending forever, approach slant asymptotes. And fortunately, these slant asymptotes are very easy to find and very easy to actually draw. What I want you to do is picture a box around that ellipse, like this, going perfectly around it. So it's sharing all of those points right there. So I think we can picture that box in the middle right there. The asymptotes of these hyperbolas are going to be the lines that connect the corners of the boxes. So like that. That was a terrible line. I should try that again. Like that-ish or something. I don't know. Make it as good as you can. It looks like that. It goes through the corners and consequently it goes through the centers as well, the center as well. So you can draw those asymptotes in to help guide you. Now we better talk about the equations a little more closely. Again, the equations are going to be so super similar to the equations of the ellipse with a couple key differences. Key difference number one of your terms is negative. We have that minus sign there instead of the addition sign there. Important piece number two, it is not important for a hyperbola. It is not important for A to be greater than B. Remember, in ellipse, you always need to think of the A value as the larger of the two values, A and B. For a hyperbola, it does not matter. A has to go with your positive piece. A has to be along the transverse axis. So notice in both of these equations, the positive term has the A value, not the negative one. The positive term has the A value. And that is important for what we're going to do later. What this is telling us is the vertices are A units from the center. Again, it matters if it's a vertical or horizontal hyperbola. That will tell you if you're going to the sides or up and down. And just like with an ellipse, we have a special relationship with A, B, and C. But again, it is slightly different for a hyperbola. Here we have c squared equals a squared plus b squared. It looks exactly the same as the Pythagorean theorem that you were most likely taught. A squared plus b squared equals c squared. But the easiest point for confusion here is that it is very similar to that of an ellipse, but it is different. Here we have the hyperbola, and remember the ellipse is a squared equals b squared plus c squared. So that's a little confusing, but I have full confidence that you will figure it out. Now, furthermore, just like an ellipse, we also have an eccentricity, and it is still defined as c over a. And just like with an ellipse, if you take special note about the different values of the eccentricity, that can help you determine what your hyperbola is going to look like. Is it going to be kind of wide, or is it going to be pretty skinny, pretty narrow? I'm going to leave that to you to investigate as you do some of these problems, because I want to get through to the actual problems. So let's go ahead and look at some of those. Here I'm going to be giving you some information. The foci are at -1, 2, and 5, 2. I'm going to start just by sketching this in. So, oh, wait, I forgot one important piece. Sorry. Let's go back real quick and talk about the asymptotes again. So, if you think about our hyperbola, imagine we have a horizontal hyperbola going on right here. We have our two vertices right there. We have the center in the middle. And I want to draw in that box that we mentioned earlier. So this center there is going to be the point H, comma, K. And now remember, you could imagine that ellipse on the inside there. And think about how we draw that ellipse. Well, from the center, we go a certain distance up and a certain distance down and get some of those points. And we go a certain distance to the left and a certain distance to the right. So remember that our value A is going to get us our vertices. So if you think about this distance right here, that's A. And if you think about this distance right here, that is B. And we want to write the equation of this line. Well, the easiest way to do that is to use point slope. Well, what is the slope here? Well, the slope is rise over run. Well, picture this little triangle right there. We know that the base of that triangle is A, the height of that triangle is B, And so the slope is rise over run. The slope is m equals b over a. Well, what about for the other asymptote? Well, the other asymptote is going to have the same slope, except it's going to be the negative version of it. So we know these slopes are going to be plus or minus b over a, assuming that our hyperbola is opening horizontally. Well, what point does it go through? Well, it goes through the center. So if we write this equation in point-slope form, super easy. Y minus k equals plus or minus b over a times x minus h. And if you look at that, it's going to look very similar to what those equations look like as well. So let's go ahead and look at these examples now. So foci is at the x value -1 and +2. And then also we have an x value of +5 and that same y value of 2. So what does that tell me already? That tells me that this is a horizontally opening hyperbola because those y values are the same, the x values are different. Vertices at 0, 2, and at 4, 2. Notice that each vertex is the same distance away from that closest focus. That's important. All right, well, what do we know? What can we figure out? Well, we can find the center here. It's going to be smack dab in the middle of these points. And so we can find that right there. And so we can tell that the center is at the coordinate 2, 2 for my center. Well, what can we then get from that? Well, we can get the distance from the center to a vertex. Is that distance right there is 2. So that tells us that A equals 2. And we can get the distance from the center to the focus, which is 3. And that is our value for C. So now we can use C squared equals A squared plus B squared, and we can find our B value. So let's plug in and simplify. So we're going to get 3 squared minus 2 squared would equal b squared, but we want b, so take the square root of all of that, solving that equation for b. So 3 squared is 9, 2 squared is 4, 9 minus 4 is 5, so b is the square root of 5. So the b value, square root of 5, is roughly 2.236, and I can use that to find, kind of help me with drawing the box to get my asymptotes in. So let's call that 2.2, so a little over 2. So from that center, if I go down that little bit, it's going to put me about there. If I go up that little bit, it's going to put me just above 4 right there. Remember, that kind of defines this box that we're going to use to draw our asymptotes. And so I'm going to sketch in my box all the way there. And then I know my asymptotes are going to go through the center and through the corners of those boxes. And I actually want to dash those in. Just like that, and dash in the other one as well. Now from this I can go ahead and sketch in my actual hyperbola, and it's going to go up, follow those asymptotes, and nice and pretty, just like that. So again, sketching this graph is pretty easy to do if you understand how to sketch the graph of an ellipse. The only difference is we have those asymptotes to draw in. So that looks pretty good, and now let's go through and identify all this information. So we need to come up with the equation. So first off, since this parabola is opening horizontally, it's telling me the x term is positive. So I need to write this as x. Where's my center? Well, my center is at 2, so x minus 2 quantity squared divided by, well, what goes underneath that? Well, again, just like we saw with the ellipse, it's really just fancy counting. So how far did we go in the x direction from that center? Well, we went 2. And so I need a 2 squared down there. And then minus my y, also minus 2, because again, that center was 2, too. So y minus 2 quantity squared divided by that b value squared, which I'm going to just write as 5. And then that needs to equal 1. And now we need to write the equation of the asymptotes. And remember, super duper easy in point slope form. That's just going to be y minus 2 equals my slope, which is plus or minus. Since this is a horizontally opening asymptote, you need to think about b is running up and down, and a is running side to side. And we're doing a rise over run, so it's b over a. And so my b value is the square root of 5, and my a value is 2. And we need to multiply that by, again, that center piece right there, x minus 2. There we have that. So we need to write the eccentricity now, which is c divided by a. c is 3, a is 2, eccentricity is 3/2. And we are done. So, pause on this and discuss it as a group if you need to, and then in a moment I'll give you another problem to do. Alright, so here is a second problem for you to do. Again, it's going to tell you the vertices and the foci. Go through and do everything that we did on the last problem. So please pause the video here on this screen and take maybe about 5 minutes, see as far as you can get, and then hit play and we can watch my explanation if you'll find that helpful, or just have a classmate present it if that seems more helpful. Up to you all. So go ahead and pause now. Alright, I'm going to go ahead and explain it. Maybe you paused, maybe you didn't, I don't know. But let's do it. So again, I like to start this by just drawing in what I know. So let's draw some axes. Vertex 1 is at an x value of 2 and a y value of positive 3. Vertex 2 is at a y value of negative 3 and an x value of 2. So my vertices are in line vertically, which tells me this will be opening vertically. My foci, x value has to still be 2, y value is 1, 2, 3, positive 6, and then of course 1, 2, 3, negative 6 right there. Which is nice because that plops my center right smack dab in the middle. So my center is the x value of 2, y value of 0. Remember what this now tells us. The distance from my center to my vertex is a, and that distance is 3. So a equals 3. The distance from my center to my focus is c, and that distance is 6. And I can use that with the equation c squared equals a squared plus b squared to solve for b, and find that b will equal the square root of 36 minus 9, which is the square root of 27, which is 3 root 3, which is roughly 5.2. So again, what does that b value tell you? Well, that tells you the other direction from that center to go out, so we can then draw our box to draw our asymptotes. So we're going to go 5.2 out to the left and right from that center. So 1, 2, let's go 1, 2, 3, 4, 5, like that, and 1, 2, 3, 4, 5, like that, and then those other points are going to be about there and about there. So remember, if we were doing an ellipse, we'd be like, woo, we're done. But it's not an ellipse, it is a hyperbola. So we need to sketch in our box to then help us get those asymptotes. Just like that. Boom, 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 boom. Boom, 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 boom. Apparently sound effects were in order. So we get our box, and then we can dash in those oblique asymptotes, which will be what actually allows us to sketch this a little more accurately. So go ahead and dash all those in. A lot of dash lines, but you can do it. And now let's go ahead and draw in this hyperbola, and it's going to go something like that. So notice it's pretty wide, this one. And so maybe take note of the eccentricity compared to that last one once we calculate it. So there's our graph, looks pretty bomber. Let's write the equation. Well, this parabola is opening vertically, which tells us that the y stuff should be positive. So I'm going to write this as y. What's it going to be? Where is it centered on the y values? Well, it's again on the x-axis. So that's just actually going to be y squared in the numerator. Y minus 0 quantity squared is just y squared over what is my a value? What is the value of half that transverse axis? Well, that is 3. So 3 squared there minus my x stuff, which is going to be x minus 2 quantity squared, again because my center is at 2, 0. And that's going to be over, well, what is that b value there? Well, here in this instance, the v value was 3 root 3, the square root of 27. So if b is the square root of 27, then b squared is 27. So you see, sometimes it's nice to write it in terms of squared, like 3 squared, and sometimes it's nice just to write it as an actual number, 27, the squared form, when the other thing would just be an ugly decimal, gross stuff. So there you go. That was probably not very helpful what I just said, but whatever. This is equal to 1. There's our equation. If we know the equation of that, we can easily write the equation of the asymptotes, because it's going to be y equals our slope, which, if you think of our slope, here now we have that distance right there. If you think of this triangle, the rise is now a and the run is b, because remember, a is always going between the vertex and the center. So now we need plus or minus a over b, so 3 over 3 root 3, which I can simplify and rationalize if you want, but for now I'm just going to write it down, and then we have our x minus 2. And again, you could put it into y equals mx plus b form, which it is, but unsimplified. But let's go ahead and simplify that fraction there, 3 over 3 root 3. Well, let's rationalize this puppy, multiply by root 3 over root 3. Well, what are we going to get? Well, we're going to get 3 root 3 in the numerator, and we're going to get 9 in the denominator. And 3 over 9 is the same as 1 over 3. So 3 over 3 root 3 is the same as root 3 over 3, which is weird. So our equation is y equals plus or minus root 3 over 3 times x minus 2. And all we need to do now is find the eccentricity. C over a, well, what was our c value? C value is 6 over our a value was 3, so this eccentricity was 2, 6 over 3. So 2 gave us a pretty wide ellipse. Think about this one right here. Eccentricity was 1.5, and maybe it wasn't quite as wide as this one. So think about, as that eccentricity increases, what happens to your hyperbola? All right. Now, one other thing you're obviously going to have to do is complete the square to then get the equation and find all the pieces. So why don't you go ahead and try to do that yourself, because you've had a lot of practice completing the square. So why don't you try to do this problem by yourself, and then we'll look at one more. Alright, so hopefully you paused this and worked towards a solution. We need to complete the square. So notice we don't have an x term. All we have is that x squared. So that's just going to stay as it is. There's not really anything to complete the square there. But let's then focus on our y stuff. So x squared minus 9. Let's factor out that minus 9, and we're left with y squared minus, what's 36 divided by 9? Well, minus 4. There we get that 4y. And then I'm just going to go ahead and move that 72 over for now. Let's complete the square. X squared minus 9, whoops, times y minus 2, quantity squared, equals 72. What do we need to do to the right side to balance this? Well, I have a 2 squared, which is a 4, but that is being multiplied by a negative 9. So on the left, I have subtracted 36, so I need to subtract 36 on this side as well. So I have x squared minus 9. Well, no, let's just do this. We're better than this. Then, let's say 72 minus 36 is 36. So now I need to divide everything by 36. So we get x squared over 36 minus, I have 9 over 36, which simplifies to 1 over 4. So I have my y minus 2 squared over 4, and now we have equal to 1. So let's think about what we know about this. Well, we know that the center is at the x value of 0 and the y value of 2. We know that since the x stuff is positive, this will be opening up horizontally, which tells us that A is 6 and B is 2, which then allows us to find C, which is going to be the square root of A squared plus B squared. So let's say 36 plus 4. So C is going to be the square root of 40. How can we simplify that? Well, let's see. How can we break 40 down? Well, 40 is going to be, let's see, 5 times 8, and 8 is 4 times 2. So let's say that 40 is 5 times 4 times 2, which then means we can simplify this as just 2 root 10, which we should get a number for. Root 10 has to be a little bit bigger than 3, because we know 3 squared is 9. So a little bit bigger than 3 times 2. We're saying this number is a little bit bigger than 6. So let's say 6 plus there for an approximation for 2 root 10. Don't feel like pulling my calculator out. But what is that? Well, that's our C value. So let's figure out what we know. We want to graph this. Maybe it's a good time to do that now. Center is x value 0, y value 2. It's opening horizontal, which means A is taking me left and right. A is 6, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Gonna go boom and boom right there. And then there was my center. Focus is a little bit bigger than 6, so that's just going to be barely on the outside there for those two foci. I'm not going to be able to do that accurately, but I can write the coordinates accurately if I want to write the coordinates of the foci. Well, the x value is going to be plus or minus 2 root 10 because the x value of the center is 0. The y value is going to be 2. So there I have written the coordinates of the foci. That's good. Alright, well let's draw in this box. What's my b value? Well, my b value is 2, which tells me that the box is going to go right there. And that's going to be up 2 from that center. So then asymptotes running like that. Remember, there's 2 of them going right there. And we could then sketch this in just like that. And again, it is reasonably accurate to the best of our abilities. Now, what else do we need to identify? The equations of the asymptotes. So again, think of the rise this time. Again, if you're picturing that as a little triangle, the rise is B, the run is A. So we need y minus 2 equals plus or minus B over A, so 2 over 6, which will simplify to 1 over 3, times, it's just going to be x, because the center has an x value of 0. So there are the equations of the asymptotes right there. And let's just identify the eccentricity. So again, C over A, so it's going to be 2 root 10 over my A value, which is 6, which we know is going to be very close to 1, because that's like 6.32 over 6. So it's very close to 1. And it's a pretty narrow hyperbola. So again, try to make the connection there. I'm going to give you one last problem to look at, and then the rest of the time is going to be yours to work. It's not a lot of time, but you only have 2 problems to do. You should be able to do so. So please do this last problem, and then pause it, and then watch the video, and I'll show you the explanation. Okay, let's complete this square. Let's collect our y stuff together, and let's factor that 16 out of the y squared. What's my other y term? Minus 32, factoring a 16 out, so minus 2y right there. Minus my 9, factoring that out of x squared. Factoring a minus 9 out of a negative 18 is leaving me with a positive 2x right there. And that's going to equal a positive 137 if I move that over. So let's complete each square. So 16 times y minus 1 squared minus 9 times x plus 1 squared equals 137. But not just 137, we need to now balance this stuff. So when we completed that square on the y term, we're going to get a 1 squared times 16. So we have added 16 to the left, so add 16 to the right. And on the right, we're going to get a 1 squared times negative 9. So we have subtracted 9 on the left, so subtract 9 on the right. So then 137 plus 16 minus 9, what is that? Well, 16 minus 9 is going to be 7. 137 plus 7 is going to give us 144. So 16 over 144, let's simplify all this out. Well, we're going to get y minus 1 squared over 9 minus x plus 1 squared over 16 equals 1. Interesting how that worked out. What does this tell us? Well, again, it tells us a bunch of things. It tells us our center is going to be negative 1, positive 1. X value, the plus 1 becomes negative 1. Y value, the minus 1 becomes positive 1. They're flipping signs. And then what else do we know? Well, we know that since y is positive, we know that this will be opening up and down, which means that A is 3, the square root of 9, and B is 4, the square root of 16. So C is going to equal the square root of 9 plus 16, which, hey, look, what do you know? It's a Pythag triple, 3, 4, 5. So C is 5, which is pretty cute. And now we can go ahead and sketch all of this. So let's sketch this now. Right there, center we said was at negative 1, positive 1. A value is 3, and it's opening up and down. So I need to go 1, 2, 3. And I need to go 1, 2, 3, like that. Now I have all of those points. And I can get my focus by going that C distance, which is going to be 5 up. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5 right there. And then my B value was 4. So I'm going to go 1, 2, 3, 4. Plop that there. 1, 2, 3, 4 there, which again, the whole point of that is it's allowing me to draw in that box, which will allow me to a little more easily and accurately sketch the graph, because now I can dash in those asymptotes, both of them, and finally, at this point, it's super quick to sketch in that hyperbola. And this one is very wide indeed, so again, make note of the eccentricity. See how that is playing a role here and what this looks like. What else do I need to know? We should write the coordinates of the foci are going to be, the x value is -1, and then the y value is going to be 1 plus or minus that c value, which was 5. So I'm being lazy. You should write that as -1, 6 and -1, -4. Two different points there. What else? Vertices. We found those vertices on there. Oh my gosh, can you tell I'm tired? I should probably just stop. Look at all this stuff. I think hopefully you get it. Go ahead and do everything. You have stuff to do. This is new, 13 and 14. This is old. Checking all of that on Tuesday. Do 11 and 12 if you finish early. Peace.